in this video, I will show you guys how to solve an equation when the unknown variable is a base in the equation. So we always try to use our prior knowledge to start with the first step. So I will try to get rid of 10, either 10 or 20, and please make sure you know that the 20 right here and the 2 right here, you cannot multiply them. Okay, I just want to repeat that you cannot multiply them. The reason is the 2 already stuck under the exponent, this one. So 2 is not independent. So therefore we cannot take 2 away and multiply with 20. Alright? So then we try to get rid of 20 or 10, and from my perspective, I will try to get rid of the small number first. So I divide by 10 on both sides. And now I have 2 times 2 raised to 3 x minus 1 equals to k raised to x power. And next I will need to use the properties of exponents to do the next step. So notice that when I have 2 standing alone, even I don't have an exponent, that's stick with the first 2 right here. However, this 2 is also known as 1. 2 raised to the first power. Alright? So then that means it's allowed me to do the next step. 2 raised to the first power plus 3x minus 1, since they have the same base. And for those of you who need to write out the rule, general rule for this, I also provide you here on the side. So we can have a raised to the m times a raised to the n equals a raised to the m plus n. Alright, so then now on the left side I can have 2, 1 plus 3x minus 1, and it give me 2 raised to 3x only. And on the right side I will rewrite everything the same. Since I didn't change anything on the right side, I just rewrite it. Alright, and then next step, I will need to know the power rule of exponents. And the power rule say a raised to the m, everything raised to the n equals a raised to m times n. So we get back to the left side. We have 2 raised to 3x. We can rewrite it as 2 raised to 3 times x, right? And that would allow us to apply the power rule of the exponents. So we can have 2 raised to the third power and everything inside parentheses raised to the x power, and equals to k raised to the x power on the right side. So in this case, we can simplify inside the parentheses. So then we have 8 raised to the x power equals k raised to the x power. And since you have the same x power on both sides, we can conclude that the base has to be the same. Therefore, the answer will be k equals to 8. And to make sure that k equals to a is not extraneous solution, we always double check our solution when we solve an equation. So check in. So then on the side, I try to double check it. So I have 20 times 2 raised to 3x minus 1 equals 10 times 8 raised to the x power. Okay. And then now I will have 20 times 2 raised to the 3x times 2 raised to negative 1 equals 10 times 8 raised to x. And now you need to know a property that when you have a raised to negative 1, that means you have 1 over a. So now I can rewrite this one right here as 1 over 2. And I just bring down everything else. So 20 times 2 raised to 3x times 1/2 equals 10 times 8 raised to x power. And now I can combine 20 and 1/2. So multiply them together, it's give me 10. So now I have 10 times 2 raised to 3 times x equals 10 times a raised to the x power. And like what we did earlier, now we can rewrite 2 raised to 3x power as a times 2 raised to the third power and everything raised to x power equals 10 times a raised to x power. And then now we can simplify one more time. We have 10 times 8 raised to the x power on the left side, which is equivalent to the right side, which is 10 times 8 raised to x power. So yes, the solution works. Alright, hopefully this video will help you guys understand a little bit more about how to solve a problem with exponents, and the base is the variable that we want to looking for.